Yep. Sean,
Starting.
Yep.
Excellent, excellent. Sorry about that technical difficulties with the live stream. So again, we've all seen this from some of our hipster developer associates, and I'm not going to say that they're wrong. Java is old. It's 22 years old. Guess what else is 22 years old? Oh wait, JavaScript. Huh. Interesting. But it's pointless to argue that. Lots of programming languages are old. It doesn't mean that they're necessarily bad. And I'm going to show you why Java is not only good, but it's getting better all the time. This talk is the evolution of the Java Collections API. We're going to kind of start with Java 1.5 a little bit and move on and show you some new concepts, new ideas that might help you in your everyday development work. We're going to specifically talk about streams, we're going to talk about maps, we're going to talk about functions and lambdas, and a little bit more. And last but not least, my name's Devin. If you have a question, raise your hand anytime you feel like it. Let's stop, let's have conversations. I want this to be an open, interactive discussion. I really don't have that much content. I'm hoping that we can have a dialogue and try and go over ideas or concerns that you might have. Because the Collections API, it's this little small wedge of the Java world, but it can have a massive impact on what you do on a day-to-day basis. So Java is old, it really is, but that's a good thing. You know why? Because every time they release an update to Java, not just the version releases, but every point release, every patch release, they're improving the JVM, they're improving the just-in-time compiler, they're improving their predictive analysis of your code. And your code just gets faster without you doing anything. That's brilliant, right? Everybody likes to get something for free. I love getting something for free. And Java is one of those languages that really lets me absorb that on a regular basis. But you'll hear this. So, but Python has yield iterators. Okay, that's cool. But Node.js has better functional Lambda support. Okay. But Scala has this, or Clojure has that, or whatnot. Okay, that's fine. But news for you, if you haven't been following it, what happened with the Java language this past year in 2018? Anybody?
A rat hole.
Huh?
A rat hole.
Well, yes. But in broader terms, Oracle gave away Java to the open source world. How many people here were not aware of that? Anybody? Wow! Wow! So I run in weird circles because I work at Red Hat and I'm a public speaker and things like that. So I talk to people like Brian Getz and Mark Reinhold and people in the Java community process on a regular basis. So, but I knew that. And the new Java 10 release, how many people here are aware that there's a new release cycle for Java? So Java will now be released twice a year. 2 times every year for the foreseeable future, there will be a new release of Java with new features and functionality. Now, what does that mean to you? That means that you're going to see some of those features that you feel like you might be missing are going to make it into Java faster, more reliably. They will do what they call a feature release, and then they will do what they call a long-term support release. So Java 10 is going to be a feature release here in, I think it's March or April. And then Java 11, which will come this fall, will be a long-term support release. That's going to be very, very cool because what's landing in Java 10 and Java 11 is something called Project Amber. And we'll talk more detail about that here in a little bit. You guys are going to love it. So the Java evolution. Now, this only goes back to 2004 Java 5, which is where you had probably arguably the biggest change in the Java language since its inception back in 1995. And that's where we added generics. And generics, as we all know, is those nice little things in the less than greater than signs that shows my collection is of this type. Okay, that's useful, But who knows what the problem with generics is?
Erasure?
Type erasure. So generics are great when you're writing code and compiling code, but at runtime, the JVM knows nothing about those generic types. It's called type erasure. So some languages have what are called reified types, which means that when you use a generic type, it follows through into the production running code. Java does not have reified types. There is still a huge argument going on through the community about whether or not we want reified types or not. That hasn't been decided. Maybe Java 14 will have it. In 2006, we added Invoke Dynamic. Anybody know what Invoke Dynamic does? Why it was really just absolutely crazy that it made it in? Anybody? No? So Java, back when it was first created as Project Oak within Sun Microsystems, had a particular instruction set for its virtual machine. Like every CPU has an instruction set. It has this many instructions. 2006, more than 11 years after the language was created, was the first time they added a new instruction to the Java virtual machine. And it was called Invoke Dynamic, and what it did is it allowed you to run code inside the virtual machine that used dynamic or loose types. And the reason they did this is to support third-party languages on the JVM. So your Scalas, your Clojures, your JavaScripts, your Rubys, your Pythons can all run in the JVM now because of Invoke Dynamic. 2011, we get Java 7, we get the diamond operator, or basically type inference for definitions of types. 2014, we got Java 8. And everybody was super excited. We get streams, and we get Lambda functions. Okay, cool. Lots of languages have had that for a while. Java 8's a little late to the party. But I want to kind of reiterate something that Brian Getz, who is the Java platform lead architect at Oracle, mentioned during his DevOps talk last year, is that first, you read code far more often than you write code. True? Yes? Right. So if you've ever looked at somebody's JavaScript or CoffeeScript or Ruby or Python that was, they're like, oh yeah, I'm using this cool feature, and you go back and look at it 3 weeks later and you're like, what the heck does that even do? Java may be verbose, but it is very, very readable. And so things that make it into the Java core language are things that improve developer experience, but do not discourage readability. They're very careful about choosing features that are going to make it into the Java language. That said, if there's a feature that you want or a functionality that you want, you can always write another language to run on the JVM. Your Scalas, your Clojures. You can run JavaScript, Ruby, Python, Ceylon, whatever. Kotlin, absolutely. And they all have their own pros and cons to them that make them desirable, not desirable, depending on the working set. And as my pipe fitter father would always say to me, use the right tool for the right job. If it makes sense for you to do your work in Scala because it gives you a certain set of functionality that makes your programming work easier, better, more performant, more maintainable, do it. You're still going to benefit from all the improvements that happen inside of the Java virtual machine and the just-in-time compiler. So now, last year, we released Java 9, and we got modules. How many people hate modules? Nobody hates them? Good for you. Because honestly, in the next 6 months, you'll probably never even have to think about modules more than to say, I got to put this Maven plugin in, or oh, I got to add this line to my Gradle build. Because your build tools are going to abstract that away from you. It's going to become deadly simple. It's already getting much simpler than it was.
Could you explain a little bit modules? I don't use Java 9 yet, so.
So One complaint that people have had, and this is absolutely great, I love having these kind of conversations, sidebar conversations. One complaint that a lot of people have had over the years about Java is that for you to even run just a simple Hello World application, you have to load the entire Java virtual machine and language to run it. In Java 9, they created this modularity capability where they've taken and created a core Java that is just maybe 10% of what's in the entire Java language spec. And then everything else is submodules, and you can pick and choose as you please. But on top of that, they have now enforced that on third-party libraries as well. So when you create an application in Java or a library in Java, you have to follow these module requirements. Right now in Java 9, there is a flag to disable it. In Java 10, that flag will go away. So basically all it is you have to create a little extra metadata in your jar files that you create that says these APIs within my library can be accessed from outside of my library. And I want to access these APIs from outside of my library when I use my library. So for example, let's say we're working on let's say we're using the Apache Common Collections Library, right? The Common Collections Library, via its metadata, via its modules.info, will say, these are the classes and methods that I'm exposing outside of my module. And it's also going to say that I need these modules to be exposed to me for me to work. That's all it is. So that has follow-on knockoff effects, though. How many of you have ever used the Java Reflection API? So you violated private methods, private classes, static methods, final methods, all of that stuff, because you use Reflection. In Java 9 and going forward, due to that modularity, you will have significantly more limited success with the Reflection API. Because if the author of that library does not expose that API in the module info, Reflection cannot get to it.
So it can get, it throws an exception in anywhere because of not accessing this.
Yep, and it's not a new exception. It's the same old exception about what is it? It's reflection invocation error exception or something like that, or access error or something like that.
But it can be difficult to find why it caused this exception. Is it easy? Is it difficult? Because
So I didn't mention it here, but one of the impressive pieces in Java 9 is the new debugging logging that is available. How many of you have ever turned on GC logging in a JVM? And out of those people, how many of you understood what you were looking at? Okay, so Tony Printezis and his team in the VM group at Twitter, along with the Java community process, completely rewrote garbage collection logging for Java 9. If you've seen it, it's beautiful, it's readable, it's coherent, it is gorgeous. And those kind of debug loggings and debug capabilities were included throughout Java 9. So
you would not know unless you run that your modules is going to break.
So, will modules break functionality? Yes. Will we recover from it quickly? Yes. It's not really going to be that big a deal. People that rely on Reflection to get things done, like for things like Java persistence architecture or Hibernate and so on and so forth, they're going to basically just write module infos that open everything, which is perfectly legitimate. If you want to allow Reflection to work, or you just want to allow everything to be accessible, go for it, have at it. But for those of us that in certain situations we want more secure, more locked down, more ability to be isolated, that's a very valuable capability. So the majority of projects that are being impacted by Java 9 modularity, what they've gone and done is exactly that. They've created a module info that allows them to open up everything plus kitchen sink. And they're recommending that if you want to use our library, you open up everything plus kitchen sink to their module. Make sense? More questions about Java 9 and modularity? Okay. So this year, we're getting Java 10. And I put pattern matching here. Unfortunately, when I wrote these slides a couple weeks ago, that was still potentially in the list of things to be included in Java 10. It didn't make it. It's going to be in Java 11 in the fall. But we did get type inference. Does anybody know what type inference means?
Is it saying what Spring does now, which is needed before? Like, you have runtime types. At runtime, if you have a different type, then you put exception.
No. So, not exactly. Spring does do some type inference, especially when you're doing dependency injection and passing things back and forth within Spring. But in this case, it's what they call local scope type inference. So now instead of saying hash map of string, comma, customer, blah, equals new hash map, diamond operator, da 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 da, you can just say var customer map equals new hash map. Just like a bunch of other dynamic languages in the world. That feature and functionality is getting greatly expanded in future versions, Java 11, Java 12, so that basically you're going to get a lot of functionality for free down the road. And that's part of Project Amber, which is Brian Getz's brainchild at Oracle. They're doing some really cool stuff. I'll show you a demo here in a little bit about one thing that's coming that'll just blow your mind. Questions on that?
Yes.
Yes?
Yes, question. No, I didn't quite get it.
You didn't quite get it. So, let me, where is my dry erase marker?
Far left corner, by the window.
Ah, here's one. All right. So, normally in Java, if you wanted to create a list of customer objects, right? You would say list of customer mycusts equals new array list, diamond operator, blah, semicolon. In Java 10 with local scope type inference, you just now say var mycusts equals new array list.
And that functions.
So where is it pick up that it's customer? List of customer?
So you can't use the traditional diamond operator, so you would actually have to put customer in here. But you do lose a bunch of this. The real important bit of this is when you have parameterized types that span, has anybody here used Java Object-Oriented Query Library, JOOQ? Yes? The record types in there can have 20, 30, 40 type parameters. And this line gets hundreds of characters long. Whereas with local scope type inference, those hundreds of characters just get replaced by 3. Yes, question?
In first definition, in list is an interface and array list is a class. In second definition, there is no need to interface actually. We just defined a class. So what about the interface?
That's a good question. And in fact, the way this works, and that was a lot of the big discussion that happened during the enhancement proposal, was do we go for list, which is the highest level abstraction, or do we go for the most directly composed or the most directly typed match? And the answer is it depends. And I don't know enough about it to speak intelligently there, But the gist is that it will try to use the most generic form that it can, given the code that's in scope. So if we had multiple lines of code that work on that list, and we only ever use the methods that are available on the most generic list interface, then it will infer the basic list type. But if we use features that are required from the array list type, then it will infer the array list type.
Question.
Oh, sorry, follow-on question?
Yes, follow. Here, the first one, list and array list. We can use common methods in list. And another definition, array list might cost new array list. We can use, in addition to list methods, common methods in the interface, we can use array list. So, how can differentiate these two definitions? Because we can define in two ways. But in one might cost new array list. We cannot. How can I? Do you understand my question?
I do understand.
Yeah, how
And
can
the
I-
answer is, smarter people than me have figured this out, and it works really well. The gist is that the new Java compiler in Java 10 and the way that they do Java compiling now in Java 10 has been improved using a new functionality they call Graal, which is the Java compiler is written in Java now, and they've put all kinds of really, really intelligent introspective logic into this local scope type analysis, and it can figure out just the minimum that you need based on the code that you run. Yeah. Yes?
So my experience with this is somewhat limited, but I think in your second example where you're using var, you have to have the type somewhere in that line. So I think you do have to say array list of customers.
Yes. Yes, you do.
Right.
Oh,
You can't make up the generic parameter around top.
Yeah.
So then it becomes from when it changes to other list, and then you have to, the diamond basis, you have to put customer over there, or does it take, or does the second line take any object as an element? One can be a customer, other can be.
So
a
if you
vendor.
don't specify a type parameter, it will accept any type that inherits from object,
So, but
which is
the-
every type.
One could be a customer, one could be an address, or there can be a phone number object, something like that.
Yes, but if you want the compile time guarantees, you actually have to populate a type in there, or there has to be sufficient code in scope for the compiler to infer the type of that list.
So it's not just coming from the line, it actually could come from.
It could come from later in that same scope.
Okay.
Now, we all know Java is a tightly scoped language, so loops have scope, code blocks have scope, methods and functions have scope, their own scope. So it is only in the scope at which the var is declared and lower that it can infer type information.
Will that make the code hard to read?
yeah, I was just thinking that, yeah.
Yeah.
No. The answer to that is no, because your IDEs and everything are going to automatically take care of that for you, because they're going to have the intelligence of that compiler code to help them out.
Is there a part of functional programming where you're trying to give the scope?
It can be. It can be very useful when you're doing functional and lambdas to have this capability to do type inference. But this capability is actually just the beginning of type inference in Java. They got the functionality out there early for people to start banging on it so that they can learn lessons from the community. Because obviously there's only so many people that are in the Java enhancement proposal process. And they can test it all they want. But until they actually get a feature out to us developers in the real world, they're not going to know of edge cases. And so this is just the tip of the iceberg when it comes to type inference. I expect great things to be moving in this area in the near future. All right. So those are a couple of the things that we've seen. But now think about this. We saw 2004 was Java 5, 2-year wait until we saw Java 6, 5-year wait until we saw Java 7, 3-year wait until we saw Java 8, another 3-year wait until we saw Java 9. But look at this. 6 months later, we're going to see Java 10. 6 months after that, we're going to see Java 11. 6 months after that, we're going to see Java 12. 6 months after that, we're going to see Java 13. For the foreseeable future. There won't be as many big changes in the Java language and the Java virtual machine on every release, but some of those smaller features that everybody likes will make it in each time.
Is this release cycle because of open source?
It's part of it. So Oracle open sourcing discussed implementing this release cycle, but came after they, understanding from talking to Mark Reinhold and a couple other people within the JCP, is that it was because Oracle was already planning on open sourcing it that they allowed them to go down that road for the new release cycle. Okay. So what do we get in Java 8? Well, in Java 8, in the Java Collections API, we added streams, mapping, this is like mapping in the functional sense, and filters. This is really useful. It's a major improvement over what we've done in Java in the past as far as handling collections of data. They've improved on that a little further with Java 9, adding features like take while, drop while on streams. And then in Java 10, we can take advantage of the type inference capabilities to reduce a little bit of boilerplate we have to write while not decreasing the readability of our code. So let's actually look at some code. I'm going to ask you to tell me if you can read my IDE. Control Shift presentation mode. Can everybody read that, or is it too small? A little small? How's that look? All right. Go on. So tell me if this code looks familiar to you.
Wow. That's cool. I like that code.
You guys like that code? This is how you used to have to iterate over an array in Java 5. Everybody remember writing something like this? Now, I mean, it could be a string array, or this could be a list object or something like that, and you could use list.size to get the index or whatnot. But this is how you used to have to iterate over things in Java. And, you know, our Python brethren and various other programmers had looked at us and said, you gotta write all that crap just to print out each item in a list? What's wrong with you people? So around about Java 6, we added this capability to do for each loops, basically. So we say for every arg in args, we print it out. This was a good improvement. This is nice. But still, quite a bit of boilerplate there, yeah? And honestly, you gotta look at that for a minute to try and understand what it does. Same way with the previous example. Then comes Java 8. Stream arguments. Now this almost reads like a sentence. We create a stream of our arguments, and for each argument, we print that line. Is that more readable? It's a judgment call. I tend to think, yes, that is a little more readable. It's very linear. It's very flowy. Whereas you don't have to try and grok a loop. So this is one of the features that Java 8 gave us, is these streams. So that's great. That's really cool. But what else can we do with streams? Let's I've got a function down here that generates a stream of strings, and that stream of strings could be optionally null, have no value, or actually have a string value in it. And nobody likes null pointer checks, right? That gets in the way of your code being readable, right? So we can filter it. So we iterate our stream and we filter out saying, if there's something present in our optional types, by the way, were introduced in Java 8, then we'll use a map function, which we are familiar with from various different other languages like Python or JavaScript, to get the actual value, but only if there is a value present, and then we can print that item. Is that a little cleaner than doing a for each loop iteration, doing a null check if else statement, and then printing out inside of that?
Yeah.
Well, arguably, quantitatively, it's about 12 fewer lines. Qualitatively, feeling-wise, reading your code-wise, this actually reads almost like a sentence. I take a stream of optionals, and I filter out the ones, filter for the ones where there is a present value, and I get that value, and I print that value. It flows rather logically, which is very nice for readability, which is why it took so long for them to decide how they wanted to implement streams in Java.
So an
But-
optional is?
An optional is kind of a holder type. So an optional is a parameterized type of some other type. So in this case, it's optional of type string, as you can see up there. And it basically says, I may or may not have a string value contained inside it, but I will let you know, which is what this isPresent method is. Everybody here, I didn't even stop to think, are you guys familiar with this syntax of the double colon?
No.
Hands up if you've never seen that. Okay, so in Java 8, we introduced lambdas, which are basically anonymous functions. There are functions that we can declare without a class, inline in our code, and we can pass final or final-like values into them. Yes? Sorry?
I missed that part. If there is a null, optional throws null pointer exception, or it is not saved.
I'll tell you about it here in a minute. Let me finish what I think I'm going to answer your question with what I'm starting to say. So these lambdas normally look something like what I've got down here in comments. So we're saying filter, our stream is providing an instance of one of the optionals, and then we're calling optional.isPresent. Why is that word generated there? That's a syntax error. Sorry about that. So instead of writing all of this out, Java 8 provides us a shortcut, and it's called a method reference, which is what this is. We're saying that on the optional type, we're going to call the isPresent method with the default argument that this lambda accepting function gives us. So instead of declaring that this lambda accepting function is going to get an optional object, and we're going to directly call o.isPresent on it, we just say method reference. That can be very useful when you're writing asynchronous code, which we will talk about at a later date. So what this is saying is when we run this stream of values through this filter, the only thing that will get past this filter are things that return true when you call isPresent. So in other words, things that are not null. And so down here, when we go to get the value out of that optional object, which is going to be our string, this will never throw a null pointer exception. And then we can safely pass it to println. Yes?
So I have an observation. I've been a C programmer for way too long. And looking at what you have here versus what you started off with the whole for I equals 0, that which is very much like C.
Mm-hmm.
The analogy I see is like it's like that, it started off, that's like reading assembly. It's that much of a difference from here to where we're spelling everything out.
To a certain extent, I would agree with you. But it's always going to come down to individual developers and individual developer teams and what makes sense for those teams. I'm not saying everybody should do this way because I love it and it's awesome. What I'm saying is, here's another way, and if it helps you, if it makes your code more readable, more maintainable, is more consumable for your developers, great, use it. I like it. I think it's cool. I don't always use it because sometimes streams can get in the way of readability, and I'll show an example of that here in a minute.
So now using this feature, it is telling us that instead of a developer doing a looping of array, you are just telling now the infrastructure to do the looping part of it, rather than you doing the manual looping of it. And the optional, is it same like the optional we have in Google Guava?
Yes.
Okay.
Very similar. Not, they don't have exactly the same methods, but they're very, very similar. Yep. What the question was, is this similar to the optional type that's provided by the Google Guava library? And while the Java 8 version of optional was based somewhat on the Google Guava library, it's not exactly. For main reason is it didn't meet their coding and style guidelines.
So could you have something but a string or null in this string? When you go through, could you have any old thing, or could you?
No.
Could you have
No, because you get a compile time violation.
Could you have any? So string and null would be at what you would have in a null.
So let's go down here and let me show you the method that generates that stream. So what I've got is I'm generating a stream of random numbers. Now this is the first tier, hard tier, stream.generate math random. That is an infinite series. How many in there, either high school or freshman in college year, had their professor or teacher tell them, don't do infinite loops? Yeah, okay. So we need a way to end this stream, right? So we limit it to this many items. But it doesn't have to just be limit. There is also in Java 9, which is after Java 8, obviously, there is take while. So we can take items from the stream while a certain condition is true. And there's also drop while. So you can start by dropping things from the stream until a particular condition becomes true. So that's another way that you can limit infinite streams. But infinite streams, let's think. In terms of one of the demos I do on a regular basis at conferences is processing the Twitter flood. Anybody ever tried to process the Twitter flood API? Yes, no, maybe so? It's a lot. And in fact, unless you pay boatloads of money, they won't let you do the raw stream. You have to provide a certain set of filters to it. And they give you a maximum number of hashtags and or Twitter IDs that you're allowed to have in a single stream. Because they don't want you to try to process the flood because it will overwhelm their bandwidth, even in AWS. So that stream technically is infinite, right? It could be infinite. I mean, if we assume Twitter will be around from here until the end of time. And that our certain hashtag filters will be there. So we may want to process an indefinite length stream of data. And streams are capable of that. And what we're doing is we're attaching pieces of logic for when a new item comes through that stream for it to be processed asynchronously. Think about that. Let's say you subscribe to a Twitter flood stream for a particular hashtag, I don't know, Red Hat Rocks maybe, and you get 20 items into your stream really quick, you process them, but then maybe it goes a week or two and you don't get anything. Your program could still be running, just waiting on something to come through that stream. And in fact, what's going to happen in the newer versions of the JVM, Java's going to optimize that, and it's going to say, put that thread to sleep, so that we can prioritize other threads. But when something does come new through that stream, it's going to pick right up right where it left off, and it's going to process asynchronously without us having to do any polling, without us having to do any checking to see if things are still awake, or a loop on our thread.wait or thread.sleeps, things like that. This is really clean way to handle asynchronous events, and it only gets better when you add on tools like RxJava or Reactive Streams, which are third-party library extensions to the Java Streams API. Questions on this? So everybody, I mean, does this generator make perfect sense to everybody? We're doing math.random, which gives us a whole value somewhere between 0 and 0.999999999 infinite. And if it's less than 0.5, we return the string A. If it's greater than 0.5, we return an empty optional. Pretty straightforward, yeah? And then we run through that stream. Now, one of the biggest things you'll see in blog posts talking about Java streams is, well, two big things. Is one we already talked about, infinite streams. You can potentially create a stream that will go forever. So be careful of that. You'll know instantly because a function will take way longer to run than you expected it to. The other big thing is that streams are immutable. Once you create a stream, you can traverse that stream once and only once. So if I were to try to reuse that same stream instance here, I would get an illegal state exception because that stream is already terminated. Two important things to remember about streams. Questions?
So, reading the stream consumes it and changes it?
No, you cannot change anything.
Well, we
Yeah.
said it was immutable.
Yep,
It's immutable, but you can only read it once.
right.
So that's what I'm saying, does reading, well, not really changes it, but.
Reading doesn't change it, no.
Well, that's why you can't have you couldn't declare a variable outside of the stream and then increment it from inside of it. Blow up.
Yes, you're right. Well, so there are ways around that. You could use an atomic integer.
But yeah, we have to do something special.
Yes, you would have to do something special. Right. Yes.
Yeah. Here, let's assume that you go through the stream, then call another method with a variable with the stream, and in that method you need to read stream again. Can you do it or can?
So
Yeah.
if you run through this stream and then pass the stream object itself as a parameter,
Yes.
Can you
with
go-
another
no.
method, and inside of another method you cannot do
Nope.
anything.
Nope,
Only
you would
one
throw an
time
exception.
to read.
I'm sorry?
You can only go only one time to the stream.
One time through a stream.
What
You
about
cannot go
all-
backward in a stream. You cannot restart a stream from the beginning. You can only process a stream forward. Yes.
I'm complete.
Third row. Sorry, third row, right here. You.
I'm completely new here, but the question is, instead of system out println, what if I had some sort of function that added something that generated a stream, another stream, using my data from this stream, and I print it out? Now would I have the ability to reread that stream?
Stream of streams.
A stream of streams. There are methodologies for handling a stream of stream. Particularly, there's a method on a stream called flatmap, which causes a stream of streams to collapse down into a single stream. But could you create a stream within a stream and then use that stream outside of that stream? No, because it violates the scope of a stream.
Okay.
So just as we were talking a little bit about Lambda functions earlier, right? When we call a Lambda function, if I had said, say, declared an integer up here somewhere, right? If I tried to operate on that integer within a Lambda function, that would violate the scoping of the Lambda function.
Okay.
And the JVM won't let you do that. It will actually throw a compiler error saying that you did something that you operated on a variable that must be final, or what's the term they use? Effectively final. Right. Right. Last row.
Has there been any discussion around using the Stream API to have multiple concurrent operations, like on a single stream?
I love that question. Let's investigate that. What if we were to do something like that? Has anybody seen this before with Streams API? Hands? Yes? A couple of you. Awesome. So just by calling parallel, or if you're creating a new stream, you call, instead of dot stream, you call dot parallel stream. This will use the default fork join pool that's built into Java 8, and it will spread those across as many cores as that machine has available to it. Yes?
For this parallel, I'm not going to like what's bad in using parallel, but is there a, in Java 10, are they improving, letting you give the thread pool instead of using the default one?
So that was already available in Java 8. So you can, instead of just calling parallel and using the default fork join pool, there is an option for you to oh no, you do it before. I'm sorry. So what you do is up here before you start the stream, you create a new fork join pool, and you assign it to be the fork join pool for your stream.
And it will pick up automatically.
Yep, and it'll use just that fork join pool. So if you create that fork join pool and only give it 2 threads on your 64 core server, it'll only use those 2 threads. Does that answer your question?
Yeah.
Yes.
So if I understand this properly, you can have one set of inputs that will get spread across the multiple cores, and each core will pick up the next one, and you don't have to worry. It's only each element will only be picked up by one core.
Correct. Correct. So the parallel stream automatically handles ensuring that each element is only processed a single time by a single thread. Now, the one thing you have to be aware of, I won't call it a problem, it's just a consideration, is that if you run a parallel stream, you cannot run a sort operation on a parallel stream. What you have to do is you have to coalesce the parallel stream using a collector. I'll show you an example here in a few minutes. And then sort the output of the parallel stream. So it's basically the whole diamond operation: expand, contract, expand, contract.
Can the streams be infinite?
Yes, streams can be infinite. So that's also something to keep in mind. It's what I was telling you earlier about down here in my example function. If I didn't put dot limit here, this stream would generate infinite random numbers.
That's beneficial for packet processing, anything where you're going to have a continuous input.
Absolutely. If you're doing a streaming API, like I was talking about the Twitter flood, if you're doing a streaming API that could potentially go ad infinitum, it's fantastic, because you no longer have to poll, you no longer have to worry about it, because that all gets offloaded to the operating system using either epoll or ipoll, depending on which OS you're on. Java doesn't have to think about it. The kernel just says, hey, you've got new data for that thread. And you process. And when it's gone, it's gone.
So in this case, if we avoid that limit call and it generates infinite stream, will the function won't return?
That's a great question. So that leads to something very interesting to think about. If I create an infinite stream of random numbers, is it just going to sit there spinning, generating random numbers, and never actually get to process what I'm trying to do with that stream? The answer is no, that will not happen, because streams are lazy. That said, there are considerations to be had. You have to structure your streams in such a way that you're not trying to pre-process certain things, or you can force it to do upfront processing. Yes?
So let's say you have a stream happily going along and processing data in the background, and your app gets a time to shut everything down command from, say, an admin interface. How do you stop a endless stream that is most likely waiting on data to arrive?
So the way I would do it is I would put some sort of logic in here using what's called a peak. A peak lets you look at the data in the stream without actually modifying it. So you can do an operation on it without changing the data. And let's say we get our string, but we're not actually going to use that. We're just going to check to see is application shutting down. And if the application is shutting down,
Is this a good use for take while?
then what we could do is we could say, oh yeah, no, that's absolutely a great use in Java 9 for a take while. But what you could also do, actually I'm thinking of this wrong, I wouldn't do it in a peak. Somewhere outside of the stream, I would have something monitoring for that, and I would say stream dot cancel dot close, and that'll stop the stream. Now, handling coordination and making sure that things got processed, that's checkpointing, and that's beyond the scope of what streams provide you by default. So then you'd want to use a tool like Kafka or something that's already going to have checkpointing so that you can go back and reprocess if you missed a message or something. But to his point, what you could do is you could add a method in here, and this is in Java 9, you can say take while application is running. And so the stream will continue processing until that method returns false. Question 4, last row.
How does thread.interrupt work with this?
Thread.interrupt will not affect this unless you intentionally get access to the default or your provided fork join pool and intentionally cancel that fork join pool.
Okay.
So you kind of have to get a reference to the fork join pool that those threads are running on, and then send an interrupt explicitly to a thread that is currently processing something from that stream. Yes, question?
So going back to my packet process.
Actually, sorry, let me back that up. You had something to add to that discussion, and it could be that I'm wrong and you have some more information that I don't.
So thread.interrupt is essentially cold. I mean, you can interrupt the thread, but until something on that thread checks for the interrupt, it has no impact. So you potentially could put something in your stream that checks for an interrupt and says essentially what take while is going to stop. But the problem, I think what Devin said originally was, you have to find the thread to be able to send it to thread.interrupt. So it's clumsy to do that through the fork.
Yeah. There are better APIs to handle that question, or that
So
issue.
going back to the packet processing usage, normally I would pull packet off the socket, put it into a queue, and process it, but there's potential for the queue to overflow. Is that same potential in the streams, or how do you not worry about?
Could you potentially overflow a stream? That's the question. Yes, you absolutely could. There are methods that you can put into your stream so that if it does get to a certain extent, you can cause it to start discarding or push them into another stream. There are even better tools that the built-in Java 8, Java 9 capabilities around that are very limited, but there are better tools in, say, RxJava, RxJava 2, and reactive streams. Great question, though. Very good question. So let's solve a problem that I'm sure every one of us has been asked to solve in a job interview sometime in the last 5 or 10 years. FizzBuzz. Let's do it weird because we want to, using streams. So this is what FizzBuzz would look like using strings in Java 8. We start by creating an integer stream of numbers from 1 to 30. And you'll notice I used ranged closed. That's an inclusive range. If you just use range, it's an exclusive range. It's inclusive start, exclusive end. Don't know why they wrote it that way, but it's a little hokey. But just be aware, if you use range, it doesn't include the last digit. If you use range closed, it does include the last digit. We change those numbers to an object, and in this case, I'm creating a simple entry, like a map entry, that has the integer value as the key and the output value as the value. And we're defaulting that output value to be an empty string. And we start processing through our stream, and we say, okay, if our key modulus 3 equals 0, then we're going to grab our value. This is actually a string builder, but IntelliJ is hiding that from you. We're going to append fizz. And we'll go to the next line. If our key modulus 5 equals 0, okay, we'll append buzz. And then finally, if our key, or if our string value is currently length 0, which means it was neither fizz nor buzz, we'll just append our key value, our number. Then we convert those values to a string, and we collect them together, joining them with, and it's hiding it from you in the ID here, it's a new line character. So what that looks like is this. Boom, done. Now, that's all right. It's not terribly beautiful. It's not super readable with all those ifs and returns and stuff like that. Now, one of the things that I put up on that roadmap for Java was, under Java 10, I put pattern matching, and it didn't quite make it into Java 10. Part of Project Amber, which is headed up by Brian Getz at Oracle, is they're going to add switch expressions. So in the near future in Java, you'll be able to do something like this with a switch statement. Who likes that?
What prevents you of...
Is it an age where you have to relearn Java?
What's that?
Is it an age where you have to all relearn Java?
You don't have to relearn. You can use this or not use it. You can do the old way just as much as the new way.
Unlearn the old Java, learn the new Java.
What prevents you of using this, having a case in one of the map functions?
There's nothing that prevents you from using a case in one of the map functions right now. The problem that you run into is that it'll end up more verbose and less readable than what I had just using the individual map functions, honestly. I tried writing it that way the first time around. So this is, my understanding, this syntax is going to make it into Java 11 in the fall. But in the enhancement proposal for Project Amber for switch expressions, there are 5 more levels deep that they're thinking about taking this. So imagine you run a switch statement on a POJO that has various different properties. In the next level, they're actually going to talk about being able to decompose those properties into lambda value or lambda fields. And the next level is being able to do that arbitrary levels deep to do pattern matching based on types and methods. That's what I was talking about when I talked about pattern matching. Has anybody here ever used Erlang? Okay, then nobody else will get anything out of that topic, so we'll skip it. Pattern matching is one of those things that's built in as a low level in Erlang, and you can define functions in Erlang that use what they call guards or pattern matches. And if you call that function with a particular value, it will find the method that matches that pattern and call the appropriate function. Java is going to be able to do that here in the near future. And it's all part of Project Amber. Yes, question, third row.
I think Kotlin has pattern matching.
Kotlin has pattern matching to a certain extent, and in Kotlin it uses a when clause. When object matches this expression, matches this expression, matches this expression. Groovy has it as well, Scala to a certain extent. Scala actually went one step further, and they do, well, Kotlin has type matching as well. So you can do pattern matching based on type and values and expressions in Kotlin. The same way with Scala. It's actually a super useful feature. And when I learned it in Erlang, I was like, this is great. And then I went back to Java and I was like, oh, bummer. But I found all kinds of other cool stuff that I like playing with in Java anyway. So does this look like an interesting syntax you guys would want to see in the near future? Go out there, upvote that Java enhancement proposal. It's JEP, I can't remember the number. You can look it up for Java switch expression, and it's on the OpenJDK website. Upvote that. I really hope we'll see it in either Java 11 or early next year in Java 12. But it is a super useful concept.
I have a question.
Yes.
Is that break with the value some kind of a return, or is it
Yeah.
establishing the value for that?
So you'll notice that my lambda function is returning the output of this switch expression, and that's what the break is saying. If my modulus 3 and my modulus 5 equals 0, then we'll break with the value fizzbuzz returning, we'll break with fizz returning, we'll break with buzz returning, we'll break with the I value turned into a string returning.
So that's the value of that expression.
Mm-hmm. Yep. We could also assign that to a variable. We could say, var result equals switch I.
Why are all the cases one?
Good question.
Why are all the cases? No, that's supposed to be I. I don't know how that ended up as 1. Thank you for catching my mistake.
The I plus.
This is why we do code reviews, right? Yes?
But I don't think you should choose I there, because you're shadowing the other I.
Yeah, okay, we'll call it II.
So just back to why are the cases all the same?
The cases aren't the same. Each case is using a different expression to evaluate.
But the IIs, I'm new to Java,
Right.
so.
We're passing in the value of I as a parameter to this lambda function. Yes?
So should it be II modulo 3?
Yes, it should. Thank you.
Yeah, switching the upper I.
Wait.
No, I got one too many.
Not right.
All right. And now that you've all embarrassed me on a YouTube live stream, thank you very much. I'm not embarrassed at all. Programmers make mistakes, other programmers catch them, we all learn from each other. That's the important takeaway here. This will actually get far more functionally capable as time proceeds and Project Amber goes forward. Like I said, decomposing those types into subtypes and parameters and functions and values and fields is going to be a super powerful. Imagine that you could do a case statement of customers, for example. And those are POJO objects, right? And those customers have a parameter of address, and I don't know the exact syntax because it hasn't been finalized yet, but basically this is saying that we would match a case where we have a customer object and that customer object has an address property, and if it doesn't, it's going to go to the next statement in the case, in the switch.
This is very much like Swift.
Hmm?
Very much like Swift.
I'm not familiar with Swift, but I'll take your word for it. And eventually the goal is to be able to decompose to arbitrary levels with this. part of what's required to make that happen is they're going to have data object types coming soon in Java. That is going to make it in Java 11. So those will be very similar to Kotlin style or Groovy style simple data objects where you just define a class with fields and you automatically get getters and setters and hash codes and equals and things like that. You'll actually be able to decompose those data object types arbitrary levels deep. So they're building the various dominoes that have to fall to be able to get to that point where we have really, really expressive switch statements in Java. Questions? All right, let's take a look at one more thing that I think is kind of useful. Is how often do you guys have to iterate through files or file contents? Yes, no, maybe so, sometimes, whatnot. Java 8 and further Java 9 added this files object type that allows you to stream the file system interface. So you can stream a directory tree. Yes, absolutely, sorry. And this is not the most readable. In fact, let me break this into. Why is it throwing me an error there? What are you trying to tell me here, IntelliJ? 1 second. There we go. Extract a method reference. There, that's a little easier to read. So what we're doing is we're doing a files.find of a particular path, in this case the current working directory, and we're saying we'll go until we hit integer max value number of files or directories. And we're going to check, is that file path an actual file and doesn't it end with an extension .xml? And we're going to stream that list of files, and for each file we're going to print that file name. That's kind of neat in how quick and expressive it is. It's pretty easy just looking at that, and we could rename that method and say is XML file to make it even more readable in that method reference. Right? So we find all files starting at that path as deep as we want that is an XML file, and we iterate over those using a for each, printing out the file name. Now, obviously, we might want to do something more interesting than just print out the file name. Let's say we want to print out all the non-commented lines in that file. So, and we define uncommented lines as being lines that don't start with a hash mark, for example. Oh, they're XML files, so it shouldn't start with that. So instead of for each, what we can do is we can say flat map, because we're going to create a stream of streams that we want to congeal down to a single stream. And we're going to take that file, and we're going to do file.lines. Actually,
Get rid of the open close paren if there is XML file.
Oh, thank you. And we can say file dot lines.
Read lines?
No, there's a streaming interface to read all the lines from a file, and I'm trying to remember. Oh, wait, I've got an example here somewhere. Stream file lines, SFLI. There we go. And in this case, it's our, F is our path.
What IDE are you using? Just out of curiosity?
IntelliJ. How did I do that? There we go. Unhandled exception. Hey, this is one of those drawbacks to lambdas already in Java 8. You cannot automatically handle exceptions in stock Java 8 stream or stock Java 8 lambdas. Now, some of the add-on libraries like RxJava, RxJava 2, Reactive Streams, they actually have functional interfaces that catch lambdas or catch exceptions, but it's not built into the default Java APIs. So what I actually have to do here is I have to say try catch IO exception and eat it. I'm just not going to do anything with that exception.
Can you exit the stream or force the stream to end in this case?
So yeah, that would cause that particular iteration of the stream not to produce anything else. And so if every item that gets processed through that stream also returned or went through that catch exception, the stream would end.
Can you kill the whole stream even if just
Can you
one item?
kill the whole stream? I don't know the answer to that off the top of my head. Let me look into it and get back to you.
Just curious.
Yep. No, it's a good question. And I just don't know the answer to it off the top of my head.
Throwing a runtime exception will terminate the stream, but not clean.
Yeah. Yeah, I don't know that if you can somehow from within a stream, well, I mean, what do we have inside the stream? I don't think we have a reference to the stream itself in any way that we could terminate the stream. Now,
You could run FizzBuzz.
you could run FizzBuzz. So now this is something we hadn't really talked about yet. Is this flat map function? We, if you recall, we showed a map function that allows you to convert from one object type to another as part of a stream process. Well, a flat map does the same thing, except what we're doing is we're taking a stream. We're taking a stream of instances that we then generate a new stream of instances from. So for every file that comes through here, we're going to create a stream of lines out of that file. And normally, if we just did a map, we'd end up with a stream of stream objects, which can be very hectic to deal with. So what FlatMap does is it coalesces those streams down into a single stream, or flattens the streams. Does that make sense to everybody? Perfect.
I have a question. If you use the map here, wouldn't the compiler complain that you are returning instead of a single object that you're returning something else?
So the answer to that, I believe, is no, it would not complain about that. But at some point, what you're going to have to do is you're going to have to flat map that anyway to get a single processable stream. Well, I mean, I don't suppose you have to. You could, in your next map, process each individual stream, which gets a little hectic and not terribly efficient.
What is it for each return?
For each doesn't return anything. It's called a terminator method on a stream.
So what's the function you're returning? Because it's return files dot something dot for each.
Oh, yeah, I needed to take the for each off. For each is a terminator. For each won't let the stream process any further. There's a couple of different terminators. There's stream.close, there's stream.forEach, there's stream.collect, I think those are the three main ones that are stream terminators. And you can't chain any more methods after those. Well, you can, but to chain into a stream, you have to start a new stream on the output of those terminators. So if you use a collector to create a Java collection out of your stream, then you could call .stream on that collection that's the output of that terminator and start a new stream. Yes?
Yeah, I don't understand the difference between map and flat map. You say that flat map returns single stream. What
Yep.
about map? If we use map instead of flat map, what will be the difference?
So if you look at the code inside of our Lambda here, we're using that files interface, and we're creating a stream of the lines in that file. And that's a stream. So we already have a stream of file names, or files. So we would be returning a stream of streams if we do a map. Whereas if we do a flat map, we would basically put those streams end to end coming out of that stream function. So there would just be a single stream and not a stream of streams.
One, okay, single, just one single stream. The other
Right.
is
So the output of a map here would be of type stream of string.
So what about flat map?
If you do a flat map, the output would be of type, I'm sorry, it would be a type of stream of string with map.
Okay.
And with a flat map, it's just a stream of string.
Okay.
Does that help explain it better?
Yes.
So flat map gives us a single stream output out of this instead of a stream of streams. Questions? Yes?
Would a stream of streams then sort of be like a two-dimensional data type?
Kinda, sorta, but very difficult to process. I'm not saying there isn't a use case for that. I couldn't think of one off the top of my head in the last few days while I've been updating this. The last time I gave this presentation, Java 8 had just come out, and so I had to revamp it for Java 9 and forthcoming Java 10. And I tried to think of a use case where you would want to use a stream of streams, and it hasn't occurred to me yet.
Okay, cool.
Question over here?
Yeah, but this is kind of maybe more a functional programming question. So a certain part of my life is spent doing things on change. So when something, when some portion of an object changes to something else, I got to do something. And I'm wondering if that's accessible to functional programming.
Yes.
Okay.
So there are a number of libraries that allow you to sort of register a cross-cutting concern as you would in aspect-oriented programming on a data type. Let's say you've got this collection of customers, and anytime there's a change to one of those customer objects, you want to generate an event that gets processed, right? Is that kind of what the...
Well, I was more kind of thinking like if you have some kind of a list, and once of objects, and once something changes in one of the objects, then the next set becomes something. Here's my states, here's my cities. The states change, keep all those guys together. If that makes sense.
So basically kind of just resort the list if something changes on a sorting key or something like that?
Yeah, not really resort, but I kind of use that as an example, but
It's outside of the scope of what I've studied up on for the purposes of this talk, but I believe I have seen tools and libraries that give you those sorts of functionalities, if I'm understanding your question correctly.
Yeah, and it's one of the questions. Yeah, it's basically.
And in the JavaScript world, they follow that kind of idea very carefully with like tools like React and Vue.js and MobX where
It's kind of like your invoice number and your lines on your invoice. The invoice numbers change. Treat the next bit of stuff together. That's the kind of that's the kind of thing I do.
oh, I see, sort of like a latch then.
Yeah.
Yeah, you can definitely do latches inside of streams.
Okay.
Yeah. And so in Java 8, they introduced a bunch of new concurrent types. So you end up with things like atomic integer and there's a bunch of atomic types, and then there's also a bunch of new types of latches that are lambda aware or lambda capable. So you can declare these new types of latches as a final value, use it even in a parallel stream environment, and it's still thread and type safe and stream safe to do things kind of like what you're talking about, I think, if I understand you correctly.
It's like grouping things,
Mhm.
the things together until
Well,
something else changes.
So
That's-
beyond that level even, you can do a collector inside at the end of a Java stream to terminate the stream, and those collectors, there are some built-in collector types that can do grouping based on a function.
Well, I will, but that's more, because a grouping is, I mean, I'm thinking, grouping kind of strikes me more at like a database-y thing where no matter what, no matter where you find them, they're put together.
True, you're right. I would agree with that assessment.
Yeah, I'm sort of thinking about, well, it changes, it changes, it's a new one,
Yep.
There's a space between you and another person.
Yep. All right. That is the majority of the demos that I had planned for tonight, but more than willing to stick around and have further discussions if anybody's interested or has any more questions. Happy to continue going for a while. Where is that error creeping in from? That's weird. Question? Sorry?
Can we get the note of this?
I will get this code up on GitHub later tonight. Because I was going to do a little bit of live coding and demoing, I didn't put it all into source code yet, but I will get it up on GitHub, and I'll post a link to the meetup discussion later tonight. So absolutely, yes.
Thank you very much.
Thank you.